crash like it was yesterday. Good. Okay, so we can actually turn off these. These aren't going to be that important. We're just going to go right into Rhino or Grasshopper. Maybe I'll show this wall because this is really going to be the only thing projecting a lot of shadows on the site. If you want, it may help to include an aerial in your Rhino model. But for this, I'm not going to worry about it. Okay, so let's go right in. So you'll see there's the Ladybug tab. In order to get anything working, we have to really focus on this first tab. You'll see this component called Ladybug. Go ahead and select that and drag it onto your screen. This is pretty much the brains of the operation. If this isn't on your canvas, nothing's going to work. There have been some noted issues with running this plugin on a Mac version. If you guys are getting some kind of red component or an orange one, don't worry, I know the solution to it. So that's just something that I have encountered with students using this on a Mac. But like I said, first thing is get this running. Then you'll see that there's a couple more components we need, such as the one where we need to download a weather file. This is what's going to be what's used to bring in information about Las Vegas. So go over to parameters, choose this Boolean toggle, hit true. It brings up your web browser with a map of all the different available weather files. This has improved a lot since I first started using this. There wasn't ever a map that you could zoom to. You had to go through this table of data, which wasn't exactly conducive. You'll see that there's 3 weather stations showing. I've mentioned this to people in the past. Weather stations that are within a airport are probably your best bet on terms of having accurate data, just because they use a much more advanced weather collecting instruments than some of these other independent ones. So I usually try and find a weather station near an airport. So I'm going to do that. Just hover over this one. It gives you some information. You double click it, it'll bring up a download. So once you have that downloaded, you can extract it. So I have this already available. So it'll come in as a zipped folder. Go ahead and extract it, which I have already. So that's there. So now we can close out of this. We can delete this part now. Go back to Ladybug. And now choose Import EPW. Again, you can see that it's needing something from over here. So if I go back to my parameters, choose Primitive, and choose File Path, I'll drag that into there. It's looking for a file to open, so I'll right click, say Set One File Path. It'll bring me to a folder where I can go and locate that weather file. This is that extracted folder, so I'm going to look for the one with the extension of EPW, so that's this one. I'll go ahead and open that. Take a second, and then it should be gray, meaning it's working. And when you look at this, you can see there's all sorts of different information that we can begin to pull from our EPW file. This first one, we're just going to focus on the solar dynamics and sun path. So it might be a little intimidating seeing all these, but we really only have to use a couple of them. We can make our sun path much more advanced based off of these different outputs that we use. So let's go ahead and go back to the Ladybug tab. And now we can begin to visualize this. So if you click on this tab, you'll see the Ladybug Sun Path. And what's nice, again, it's going to be a little overwhelming seeing all these inputs, but here's a quick tip for you. When you see these descriptions on the left-hand side, if there's an underscore just on the left-hand side, that means that's the only thing that's required. In this case, we only need a location. If it has it on both sides, that means it's optional. So, like I said, some of these require 1 to 3. It doesn't require there to be an input for all of these. So again, it's always kind of looking at what it's looking for and making sure to put in the right pieces. So this one only needs a location. So I'm going to go ahead and drag location into there. And you can see immediately it creates our sun path. What's nice is that depending on the size of your model, you can change the scale of the sun path. So if I go down here and see sun path scale, I can create a slider, so you can either make it 2 or 3 times bigger, or you can make it smaller. So I'm going to do 0.25 less than 3. And that'll create a number slider between 0.25 and 3. So I can go ahead and drag that into my sun path scale. So you can see that's a little bit too small. And I can go ahead and just drag that to whichever one. Again, this is going to be based off of how you want to present this. So if you want to show the sun path fairly tight and zoomed in, then you'd use a smaller one versus a larger one when you have a larger site. The key thing to know that your geometry doesn't have to be within the sun path diagram. It can be completely outside of it and it's still going to work. This is only giving you a representation. The important thing that's coming out of this is that's giving you a sun vector. That's just a direction. It's not a physical thing. So you can know that wherever that sun is on here is that it's still going to be influencing the site at that direction, whether it's inside your sun path or not. So I think sometimes people feel like they need to make sure that their sun path is kind of encircling your site. You don't really have to worry about that. Again, it's just a visual representation for reference. I'm going to keep it inside there just for the sake of keeping it nearby. You can see it gives you a default time. That's what this yellow circle or sphere is, representing the sun. So what's nice is that you can change the time of day, month. I don't know if you can do year, no. So just hour, days, and months. So you can get a pretty accurate description from this. As you can see, this is again just giving you one time. What's nice is that you can get a series of times. You can get more than one. This is where it's important when you start doing these sun rows, is that if you want to see a series of shadows being projected from this, we can look at a multitude of hours from that. So the other thing that we can do is also include temperature in relation to that sun direction. So we may be we might find it just kind of generic to figure out, okay, I'm going to find the summer equinox, the winter solstice, and then the different oops, sorry, I said that wrong. But the summer and winter solstice, and then the spring and fall equinox, just because we're familiar with those times. it may be important to look at those, but it might also be important to understand what the shadow patterns are during the hottest time of the year or even the coldest time of the year. And again, that's something that we can pull from this. So what I'm going to do is I'm going to go ahead and drag this dry bulb temperature, so this is your air temperature, into my annual hourly data and put over here. So now it gives me a color and also a legend. It's saying at this time of the day it's 12.20 degrees Celsius. We can convert that to Fahrenheit, so don't feel like you need to explain everything in the Celsius degree. The next thing we want to do is figure out maybe the temperature. So we need to find, in this case, the hottest time of the year. We could manually just change a slider for each one of these incrementally until we feel like we have found the hottest time of the year. But when you find out that there's over 4,000 different temperature readings from this, you might not want to do that. So again, we're going to go through the process of how you can filter out all this data. Like I said, we could plug in sliders for these to look at very specific times, or we can look at an analysis period. In this case, I'm going to look at an entire year span. So I'm going to go over to here, choose Ladybug analysis period. Let's give ourselves some more real estate. So I'm going to go from month to month, day to day, and hour to hour. So the first one's just going to be a 1 for first month. From day 1, and from hour 1. Then I'm going to go to December, so that's where we enter 12. Day 31. And hour 24. Let's continue to give ourselves a little more room. So now we can see that we've given an analysis period from January 1st, hour 1, to December 31st, hour 24. So I'm going to drag that into here, and this is going to take a second because it's looking at a whole ton of data. So now you can see that our sun path is showing us essentially a sun for every hour and day of the year, from sunrise to sunset, as well as its corresponding temperature relation. So you can see that the blues are your cooler temperatures and your reds are your hotter temperatures. Makes sense. So again, it's all about how do you filter this data, because right now it's just a crap ton of information. So the way we can do that is going down to our conditional statement. If you hover over it, it gives a nice description to understand how it works. So what I want to do is figure out, again, that hottest time of the year. And it's looking for readings in Celsius. I don't know the temperature conversion off the top of my head, but luckily they have a plugin to do just that. So I'm going to do Fahrenheit to Celsius because I understand Fahrenheit readings. I'm going to do a number slider from 90 less than 125. I'm going to assume it never got over 125 degrees here. I'm going to pull out a panel real quick to use for reference. So we can see 90 degrees is 32 degrees Celsius. And if I slide this, I can see what that temperature conversion is. I'm gonna stick at about 100 degrees Fahrenheit. That should help me out a bit, and gives me 37.7 degrees Celsius. I'm gonna go ahead and round that up to 38. So going over my conditional statement, I can see that you need to enter something that says either A is less than or equal to a value. So I'm only looking at temperatures greater than 38 degrees Celsius in this case. So I'm going to, again, create a panel that says A greater than 38. And then I'll go ahead and drag that into there. Again, just a simple algebra operation here. And again, it's going to filter it down. The color scheme kind of screws up because then it just says whatever that lowest degree is blue and then the highest degree is red. So it's not necessarily that they are colder. It's just within that color spectrum, it's at the other end. But you can see from that, which is kind of cool, is that there's 332 hours of our year where temperatures are above 100 degrees. So you can really start to create some interesting infographics in that sense. So I think that's pretty good. Again, I can incrementally raise this in order to produce less results, but I can even work from it over on this end. We can see from here that there's the sun position, HOY, that's just the hour of year, as well as selected hourly data. So again, what I want to do is find that hottest day of the year. So instead of just defaulting to June 21st, because it's actually several days away from that. So now I can go over to sets. I'm going to choose sort list. I'm looking at, I want to sort it by temperature, so I'm going to choose the select hourly data, and then its associated hour of the year. So I'll drag this into there. It's going to sort it numerically from the lowest value to the highest value. So 38.3 to 44.4 degrees Celsius. I'd rather know what that hottest temperature is, so I'm just going to right click, hit reverse, and hit reverse for this as well. So they're both going now from high to low. So now I see that 44.4 degrees Celsius is the hottest temperature during the year, as well as when that hour is. Again, I don't know what hour 4,430 is, and I don't really want to try and find that out by myself manually. So I'm going to go back over to Ladybug, go to the extra, and choose, I believe it's Ladybug DOYHOY. Nope, not that one. Sorry, it's this one. So Ladybug day, month, hour. So now again, I can drag my hour of the year value into here, and it's going to give me the day, the month, and the hour, or the specific date. In this case, the 4th of July. I wonder if it was just calculating from all the fireworks. I don't know. So, like I said, we can see now that we have a specific day that it's the hottest time of the year. So that's good to know. I'm surprised. Thought it was a different date last time I did this, but oh well, we'll just use that still. Okay. So this was a little bit of work just to find that, but now again, it's nice to know the temperature readings by day. We can look at it from this solar path diagram, or we can also look at it from a 3D chart, which could also be useful in our presentation. So again, I can go to visualization and choose Ladybug 3D chart. Again, it's asking for some data. In this case, I want to Still use that dry bulb temperature. And then also use the same conditional statement. So I'm going to just drag this into here. And I'll turn this off briefly. And you'll see that it creates this really wacky 3D chart. Without that conditional statement, it's going to show me all those hours. If I look at it in plan view, you can also see here. So it gives you a little better understanding of all those days of the year where the temperature is above 100 degrees. You can obviously change that to see the hottest time of the year or the coldest time of the year. Again, what's great about the whole idea of using this parametric modeling and plugin is that we have complete control over those kind of things. So I'm just going to go ahead and delete that. Again, I know the date now is July 4th to look at. So you may want to copy this and or keep it and then go ahead and copy it for the other part of this. It's up to you. I'll do that so that I have one that's just telling me again what those days of the year are for that temperature variable. Then I'm just going to remove the analysis period. As well as this input. Oops. I don't need conditional statement anymore. Okay, so that should be good. So I'll turn this back on. Go ahead and find my model. So, okay, now getting back to creating that sun rose. This is again just showing a model of the wall that's surrounding your site. So you have the 13-foot wall as this backdrop, as well as some 8 feet walls. In order to do this shadow study, you need the objects themselves that are creating a shadow, as well as some kind of base surface that the shadows are being projected onto. Hopefully they update it at some point to just project onto a C-plane, so you don't need that as well. But for now, we can do it this way still. So now we're going to give it an actual date and time. So again, we know that the day is July 4th. So let's go ahead and hit 4 for the day. The month being 7. And now what I'm going to do is actually look at all the hours for that entire day. So I'm going to use the series component to do that. I'll go over to sets, series. I'm going to use this to generate that incremental values for hours. So I need a start number. In this case, I'm going to assume that the sun is up by at least 6 a.m. So I'm going to right click, enter 6 for set number. Step size 1 because it's going to look at every hour. So I'm going to keep that at 1. And then count. So I'm going to say it's probably going to be light from 6 a.m. to possibly 9 p.m. I'm not entirely sure. We'll find out. So from 6 to 9, that's 13 hours. So I'll do 13 as a slider. So maybe I'll do 12 to 15 just in case. And then just move that to 13 to drag in there. And what this is going to do is basically generate all those hours. So 6, 7, 8, all the way to, in this case, 6 p.m. Meant to do it that way. Okay. So let's drag that into our hours. So it looks like we could have probably added a little bit more, but again, what's nice is it's showing me now on that day what the temperature is at 6 a.m., 7, 8, and so forth, all the way to, I believe this goes to 8 p.m. So you can see these dark reds are definitely the hottest time of the day from about noon to 7. So let's go ahead and now create that shadow study. So you can see the big thing that's coming out of here is the sun vectors. This is what's using to make these shadow projections. Going back to Ladybug, all the way at the end, you'll see this icon says Ladybug Shadow Study. That's what we need. We can go ahead and drag, before we do that, what's nice is it gives us our shadow projection as well as the shade. So this will be the one time I let you guys speak. So what's the difference between shadow and shade?
The shadow is what's being projected based off of an object.
Based off the sun.
Based off the sun, and then shade is the temperature. I believe it's the temperature difference between.
So there's an object that's giving a shadow projection, right? So in other words, for the most part, everything's three-dimensional, it has some volume. So there's the side that's being hit by the sun that's casting the shadow. What's the opposite side then? What's that? The shade, right? So understanding that there's a shadow projection as well as shadow or shade on those objects. So you can even start to analyze the shade of components. For this, it's probably not going to be as significant. So what's nice, you can zoom in, you can see this minus sign, and you can go ahead and remove that. That's just going to help make everything process a little bit quicker, because for the shadow study, it gets pretty intense in terms of using your computer processing power. So like I said, this is why we use more simplified geometry than very intricate. If you want to take that risk, go for it. You've been warned that it may potentially crash your computer, so you can live dangerously and do that. Maybe save right before that. That'd be another sound advice for you. So let's go ahead and do that. So yeah, let's go ahead and do that and save just as I'm speaking of this. Okay, so what I'm going to do is I'm going to select both my base surface as well as the object that I want to project a shadow, in this case, the walls. Go back to parameters, use the brep component, just right click and say set multiple breps, and go ahead and turn that off. So again, you can just put both the base surface and those objects into the same component. Go ahead and drag that into there. And now the fun part, drag the sun vector into here. This will take a second. Oh boy. That is weird. Why is it? Let's try and do them individually, I guess. So let's go ahead and unplug these. Set this as the one brep. this as a surface. Let's try that again. Okay, so that makes sense. This isn't projecting onto anything, so it shouldn't have a shadow. When I drag this into there, fingers crossed. Huh. That is odd. Let me see what happens if I don't delete that one output. And I don't need this. Maybe this is screwing it up. Nope, still doesn't like that. Weird. So like only looking at these first. I don't even know if it's looking at those. Unless they have done it, where you do have to stay within that sun shadow box. But, I promise it does work. I don't know why it always gets nervous when I'm presenting in front of people and decides not to work. Wow, so maybe they did screw it up in that sense, but okay, well, there it is. It's doing something funky where it doesn't actually like that. I swear before you could have this anywhere and it wouldn't really matter. I'm seriously going to be annoyed if that's what the case is now. Has anybody been able to follow along with this? No? So it's a good thing I was recording, right? Huh. So it's not actually changing the shadows, but it is working. I guess I had to just kind of fiddle with it in Rhino space, but I am going to remove the shade though still. Because you can see, like, this is what I was talking about, how there's these curves that are being projected onto the walls. Those are the shade curves. So if I delete that, it'll just give me the shadow curves, which is nice. Give that a hot minute. So like I said, what's nice about this is that, again, the seeing what all those shadow projections is at least interesting, but it still doesn't tell us a whole lot. When you start to go into, or what I suggest is that you would go into Illustrator, bring in all these shadow curves and determine which areas are receiving the majority of shadow or shade throughout the day, as well as areas that are essentially exposed for the remaining part. So again, this will be in the lecture notes that I sent to you guys, where you can begin to see that visually. But so essentially what you could do is say, like, to zoom in, show here's where it's receiving 12 to 14 hours of shade versus these other areas that may be receiving 4 to either 1 or even no shade throughout the day. You can even see that when it gets really far into the day and during the summer, that you do get some sun coming in and projecting outside, but probably not enough to still allow for vegetation to grow. So it's nice you can do that for, again, the warm days, as well as going through that same process and determining the coldest day of the year and seeing what the shadow conditions are there. So as I'm highly suggesting it or recommending, you do more than just the hot time of the year. Maybe, possibly, hopefully, yes, do also for the coldest time of the year. So we have a nice comparative analysis. Yeah, so like I said, fairly simple to do the shadow study with this component. So the next part that we're going to look at is then now the building orientation. So yeah, I think that covers, yeah, the majority of it. And like I said, you could also, let's actually go a little bit further with this. I'm going to again drag this conditional statement, or I'm going to drag the dry bulb temperature down into there again, so I can see what that temperature relation is. The scary thing is I don't even hear my fan going off of my laptop, so. Usually on my old laptop, this is the moment the fan would go off. So I don't know if it's just taking a long time to compute it or is having difficulty computing it. All right, so there we go. So I'm going to go ahead and turn this off. And what you can do is, I'm not going to go through the rigor of it for this workshop, but what's nice is that you could do just like a gray shadow overlay with this, or you could give it the corresponding colors of the temperature during that day. So we have a better understanding of where are those shadows during these hours versus the shadows in those cooler hours. That could be interesting. But we can also even just overlay them this way as well. So I'll turn this off, go over to parameters, do this and drag it in as a surface so it converts all those curves to a surface. Turn the preview off. Let's do custom preview. And then let's give it a swatch. So color swatch. I'm just going to give it a very faint gray, as well as having some opacity. Maybe we'll make it a little darker. And then, actually, let's do one more thing before this, so we don't have all these lines interfering. I'll go ahead and convert this to a mesh. And then drag this into there. And let's turn this off. So this is more or less what you'd probably want your outcome to look like. So if you do this kind of light gray overlay method, you can make it a little bit darker. You can really start to see where they're overlapping the most and having the most shade on your site. So that's the idea behind the visualization, that by giving it that opacity, whenever that geometry starts to overlap with each other, it becomes darker, implying that it's receiving a lot of shade. So, yeah. So, I mean, if you're uncomfortable bringing that into Illustrator, you could always change the display settings in Rhino itself. So maybe give this like a white color. You can always do like a print screen of that and then bring it into Illustrator and label it. So like I said, now that you've kind of got this all set up at this point, you can simply change some of those hourly data values and have new results fairly quickly. Okay, so moving on, let's do the last part with the building. Let's go ahead and turn some of these things off. There we go. All right, so for this, you can either use a detailed building or just a simple extruded rectangle to represent your building. Again, the reason we're using this box is to look at the relationship between these different faces of the building with the sun. So what's nice is, again, I can look at what this building looks like on the hottest day of the year by keeping these parts of the component. Let's go ahead and now reference this geometry by using the BREP component, set one BREP. You can go ahead and hide this now. And so with that, I'm going to give it a transformation or a rotate operation. So I'm going to double click the screen, hit rotate, drag my geometry into there. Let's turn this off. I'm going to create a point for it to rotate around. So I'm going to use the volume. Again, I don't expect all of you to understand how to use Grasshopper. The idea is, because I'm doing this video, you should be able to at least follow along and slowly get more familiar over time. Use studio time to get that additional feedback. For me, I just really kind of learned Grasshopper hitting the ground running like this, and then I went back to learn the basics. I think some of you have the basics already, but this should help. Oops. So again, I'm just using this as my point of rotation. It's asking for angles and radians. I have no idea how to rotate things by radians, so I'm going to change that to degrees. Something, again, I'm more familiar with. I'm going to do -1, let's do -90 less than 0. I'll drag this to 0. And what's nice with this is I can simply rotate my building to be set up to match my building or my solar orientation. So I can turn this off as well, so that's not interrupting. And the next thing we need to do is create a mesh out of this. So I'm going to turn this off, go to my mesh tab, do mesh from BREP. So pretty similar geometry. The only thing that's different is how it's going to be read with this part of the Ladybug component. Yeah, let's move this up to here. Okay, so now I'm going to deconstruct this mesh. And the reason for that is because it's giving me the face orientation of all those different building sides. So that's what this N is, the normals or the vectors. Basically what we're going to do is compare these vectors of the buildings with the sun vector. A pretty easy way to understand that is I do this all the time just to see how it works. If I just go to curve, line SDL, it's asking for a point to create a direction from. So that's this direction. That's our vector. You can see when you hover over these components that it gives you this icon right here. That's usually a good tool to figure out what it's asking for, even though the labels may be different. So this one's calling it normals. This one's saying direction, but they have the same icon. So that means they're the same thing, even though they're labeled differently. Now when I zoom into here, let's make them a little bit larger. You can see this is basically what those faces are pointing to. So this one's pointing there up. Pretty common knowledge. When we get into more advanced things like terrain modeling and comparing those angles, this becomes a little bit more helpful. I mean, this is pretty straightforward with building orientation. So like I said, we're going to compare these angles with our solar angles. So looking at this one, and then again, picking a specific date or a time. I'll delete that real quick. And I can see then, so the date was 4th of July at 1400 hours or 2 p.m. So I'll do 14 again. Drag that into there. So now I have a specific date or a specific time. Again, I don't really care about this dry bulb, so I'll unplug this just so it's less to process. So like I said, we're going to compare all the angles of these building face with this sun angle. So let's go ahead and delete this. So now if I go to my vector tab, vector, angle, so comparing two angles. So we have the angle of the buildings as well as the angle of the sun or direction of the sun. And that's giving me angles. Let's go ahead and turn these off. And now what's nice is that I can give each one of those faces of the building a different color corresponding to its angle difference with the sun. So I'm going to go to math, do min and max. So this is giving me the highest angle difference and the lowest angle difference. So the lower that angle difference is, the more they're matching up, versus the larger that angle difference is, the further they're matching up. Make sense to some degree? So we're going to deconstruct this domain. I'm going to go over to parameters now and choose this color slider. So I'm going to look at all these angles. So I'm going to drag that into this T value, as well as the high and the low. I'm going to right click on this to change the color preset to this one that's a little more appropriate for the sun color coordination because it matches the ladybug as well. Now I'll go back to mesh, construct mesh. You can pretty much match up all these parts, so vectors or vertices, faces. Then the last thing we see on this is asking for color. So now we can drag this slider into here. Now we have a nice corresponding color. Right now it's kind of working the opposite. The blues representing that high temperature, or the blues representing the high temperature. So if I just flip these, it'll make it appear a little more accurate. So you can see the warmer colors are the areas that are getting heated, versus the other side, it has more of that blue hue to it. So this is showing how much solar radiation it's getting based off this orientation. And the reason we did this part with the angle is now we can see what happens if we start to orientate our building. So if we start to orientate it, the colors change slightly. Maybe not as much as I'd hoped for. They should change a little. So you can see like the back side of this building has more of this blue hue because it's clearly not getting any sun, versus when you start to get it closer, it starts to warm up a little more. And now the back side is oriented. So determining how you want to cool this building, the way this works is that you want to reduce that thermal heat gain to a building. The larger the surface, the more heat gain it's going to have. So if you start orientating your building so that this face is getting the majority of that sun angle, you're limiting to the heat gain to just be on this side of the building versus on all the other sides. So this starts to help you determine the optimal building orientation. So that being said, I'll go ahead and pause this or stop it.